Hi everyone, this is Prats and I will be your guide to this session of Create classes where we will be learning and exploring some exciting things. So in this session I will guide you as to how to add 4 infrared sensors on our board and explain to you a simple controller file which we will use to run a line following board. So here we are inside our robot module and we move to the hinge joint node and we will add a new node. This node will be a distance sensor node. Here we go. We shall add it. And the first important thing to do is go and name our sensor. Naming our sensor is really important. We will be using this name while writing controller code to access the sensors and hence read values from it. So we have named it as IR external right. Now I want you to go to the type and change the type from generic to infrared. Now we will proceed to provide coordinates for our sensors. An important thing to observe here is in viewport's environment, the plane parallel to the ground is actually the XZ plane rather than the XY plane. Hence the Y coordinate we are providing will be constant for all the sensors as we will be keeping all of them on the same height. So here I have provided the coordinates for the rightmost sensor. Next we move on to provide the rotation coordinates. Here our main aim is to ensure that the x-axis, the axis presented in the red color, faces downwards, as the rays coming from the infrared sensors will be coming in the x direction. The next we will proceed to provide some physics to our sensor. So we will add a physics node and we can name it as IR physics. So I have named it and we will proceed to the bounding object at the end. Now let's provide to the children node where we will be providing some basic properties to the sensor in form of shape. So here I have added a shape node which contains an attribute appearance. We'll go click on PBR appearance and add it. In the PBR appearance we can set the base color as 011 to give it a bluish color. We can set the metalness as 0 and that's all we have to do in the appearance section. Now moving on to the geometry part, we have to assign some shape to the sensor, right? So let's select the box node. As the size is pretty big, so we will just scale it down by a factor of 10, giving the dimension of cube as 0.01. So there we go, we have our sensor right here. Now we can name this shape as IR shape. And what's the benefit of naming our sensor, you will find out later. Now I want you to come down to the lookup table and change this value of 0.1 to 0.05. This will limit the range of the infrared sensor to 0.05 and all other properties such as aperture and resolution are best at their default value. Now coming to the bounding object, we can use the node we have created earlier. The shape node we had created earlier, that is the IR shape. We can add it and this forms a bounding object around our sensor. This might be tough to visualize right now, but while adding the second sensor, you can visualize it. So let's revise what we have gone through till now. In the properties, we have added appearance, and geometry box we have added the size and the shape of the box. We have added bounding box and physics. We have adjusted the lookup table. We have adjusted the type, and we have also named our sensor at the starting. Now let's move on to adding our next sensor. which will be our right sensor. So here you go, I click on add new, I select another distance sensor node and add it. There you go. Like I said, the first thing we should do is give a name to our sensor. Here you go, I have assigned it to IR right. Now we go to the type and assign it as infrared. Now the next thing is giving it the coordinates. I will also assign the same y coordinate as I had assigned the extreme right sensor, which was minus 0.0275. Keeping it constant, I will just be changing the z value. So now you can see the board. In the board, the coordinate axis is taking shape. I will also adjust the rotation so as the x-axis is facing downwards. Here you go. Let's now give some physics to our sensor. The IR physics we had defined earlier will help us in that. We will select it. And now let me go and use the bounding box we had created earlier, which was the IR shape. Now if I select this, you can see the skeleton of our sensor being formed here. Whatever bounding box is being defined, the physics will be applied on it. It provides some collisive properties to our sensor, and hence it's essential to assign a bounding object to our sensor. Now we will move on to children and we will give it some properties, such as we'll select the shape, and like we did in the earlier case, we will select the appearance as PBR appearance. We will set its base color to 011, which will give it a bluish appearance, and we will set the metalness to 0. We will provide the geometry as a box node. We will specify the size. You can see our second sensor is now taking shape, and there we go. Our process is done. And of course we have to adjust the lookup table too. The second column in the lookup table, 1e plus O3, you can see that's actually the value of 1000. So the reading of our sensors will be in the range 0 to 1000. That's what the second column of the lookup table specifies. Now we have got two sensors, so we will just cut short our work and copy paste this node and rename it as IR left. The only thing we need to change here is the location. As right and left sensor will be symmetrical, I will just provide the negative of the z coordinate provided in the right sensor. There you go. You can see the left sensor appearing on our board. This is our extreme right. So I will copy it and again paste the same node and rename it as extreme left IR sensor. That will be IR EXT left. There you go. So this all is actually a pretty simple process. There you go. Our 4 sensors are ready. We will see soon how these 4 sensors will help us to code for a line following bot, which will follow a black track. You can have a better view of these IR sensors and the rays coming out of it by pressing Ctrl plus F10 to have a orthographic projection view. There you go. See you soon. Now we shall start to tackle the topics related to programming robot controllers. This session will introduce you to the basics of robot programming in VBots. You will see how to link VBot's environment nodes with the controller API, how to initialize robot controllers, and how to get sensor values and how to command the actuators. So, as you can see, this is our world over here. As you can see, our bot is ready with all the sensors on its body. We have the IR sensors over here, and we also got some distance sensors on each of its side. We have a track, we have a black strip which has some width, and the bot is expected to follow the line. Okay, and on further ahead you will also learn how to do obstacle avoidance with the help of distance sensors, but for now our aim is to follow the track. So inside the robot module you can see we have an attribute called my controller, or the controller. So inside the double quotes, whatever name you see, it's actually the name of your controller file, which will command your bot to move in the world. So in order to create your own controller file, you should move to wizards and select new robot controller. So click on next, select your preferred language, give some controller name, let's say ABC, and click on next. So it's showing you a conclusion that these files will be created, and it will also open the file in the text editor. As I finish, uh, you can see on the right a text editor has opened up some file. It has some sort of basic syntax and lots of commented code. So the first thing you must do in a controller file is to import the robot module from the controller directive. And the second thing is, here you can see we have to create a robot instance. The third thing is to get the time step of the current world. So what is this time step? You, we define a variable time step in order to specify the duration of each physics step. This duration is actually in milliseconds and is the regular interval in which the controller interacts with the VBot's environment by sending some actuator commands or receiving some sensor values. So after that you have this part of commented code where you will where it has shown how to access values from your actuators, and in the end we have a main loop uh, where we perform simulation steps until the vbots is stopping the controller. So this is the main loop where the actuator commands will go in, where you will be actually passing commands that will be reflecting on your board. So this is the basic code or basic code template we have to follow while writing any controller file. So after you complete writing your controller file, you have to go to your controller attribute inside your robot module, select it, and choose your own controller. It should be ABC that you have created. But in my case, I have already created a line follower controller which will control my bot. So let's go over this code and see how this works. As you can see, I have already included all the basic or basic syntax or the basic code snippets that the controller file had to offer. I have included the robot directive, I have created its instance, I have defined time step variable, and also in the end I have my main loop. So what are we exactly doing out here? So after declaring my time step variable, I have taken a motor list, which is a list, and as you can see, it contains the name of the nodes of my actuator nodes, which are the right wheel, right front and rear wheel, and left front and rear wheel. Similarly, I have created a sensor list which contains my IR sensor node names, which is IR right, IR left, extreme right, and extreme left. I have created two dictionaries named motor and sensor. Here you can see as we iterate over the list, we assign a key value pair to the dictionary. Here we access the motors by using the robot.getDevice function. We pass the name of the actuator node as the parameter. Make sure you use the correct node names to access the motors or sensors, else there would be an error. So with these three commands, we initialize the motors. We use set position and we also use set velocity to set the default initial velocity to 0. Similarly, we iterate in the sensor list and we initialize all the sensors. So these are some default code snippet, or you can say the default procedure how you can access and initialize your actuators and sensors. Now it's time to command the bot. Now we go inside our main loop first and we access the values of our IR sensor with the help of these four statements. Specifically, we use the get value function to access the value of the IR sensor. I have stored the value or the reading, you can say, of the IR right sensor in the right value variable. Similarly, I have used left value, right external value, and left external value to store the corresponding readings of the other IR sensors. So, in order for you to understand at first, I have printed the values before going into some logic as to how to command the bot. So let's run this and find out. Okay, you can see down in the console window, we have the readings of all the IR sensors over here. The extreme right, left, and the extreme right sensor have a reading which is significantly low than the right and the left sensor. Right and the left sensor have a constant reading of 1000, which indicates that they are over the black track and have a significant higher reading than the extreme left and the right track. If you take a closer look on the board, you can see, okay, let me just, you can see the middle two sensors are over the black line. The two middle sensors are over the black line and the two extreme ones are over the over the brown floor, you can say, and that's why they have different reading than those of, oops, sorry, than those of the sensors in the middle. You can also see these sensor readings on a graph. Let me show you. Okay, if you double click on the board, some sort of window pops out in the left hand side of your vboards panel, and if I maximize the panel you can see the graph readings over here. The extreme right and the extreme left sensor have a reading of around 500. The check boxes means that they are active and running. So we have the four IR sensors running, and the right and the left have a significantly higher value. As I've said, they are over the black track. That's why. And as you have seen, we haven't initialized the distance sensor yet, and hence they have no reading. So this is a good way to realize the sensor readings. So I will just minimize this and cut this out. Now we have readings over here. Now let's move over some logic, how to give the bot some velocity and how to control its direction. Although I have taken or accessed the values of all the four sensors in order to show you how the readings of the IR sensors look like, but I have used only the two middle IR sensors in order to control my bot. So we will find out in the end if these two are enough to control our bot and move optimally in this track. So let me go ahead and uncomment this piece of code. So these statements form my main control statements, as per which these instruction will guide my bot how to move in this track. So I have taken a threshold value of 900. As you have seen that the values which are uh, sensors which are over the track give a reading of over 900, and the sensors which aren't over the track have a value well below 900. So I have taken this 900 as my threshold for classifying the track as black or non-black. So here is my first control statement, which looks like this: if the right value is less than 900 and left value is greater than 100. So what this statement signifies? It signifies that the bot has drifted towards the right. The left sensor is over the right over the black track, but the right sensor isn't quite over the black track as its reading has deviated below 900. So what I do is what I call a function named set motor speed, and I pass two values in it, which is 5 and 0. So let's move over to the definition of the set motor speed. It takes in two values as parameters, and it sets the speed of left and right, front and rear wheel. As you can see, we are following this process. First we have initialized the motor. Then we have accessed the motor. Then we have used the set velocity function. We have used the set velocity function to provide it with some speed. So I am assigning the right front and right rear wheel with same velocity, and so is the same case with left rear and left front wheel. So this is the case when I pass 5 and 0 in this function. I haven't given any velocity to the left wheel, while I have provided some velocity to the right front and rear wheel. So what it will do, it will make the bot adjust its line by moving over, by turning somewhat to the left. And if the second control statement is just the vice versa of the first one. If the two control statements aren't applicable, so these two aren't the case, then we have the default case, which means that both the sensors are giving readings over 900. They are over the track and the bot should follow a straight line path. Hence, I have passed same values 5 and 5 in this function, which will give same velocity to both the right and the left wheel. So I guess I have taken you through a very detailed explanation of how a controller file works. So now let's run it and see it in action. Okay, let me reload this file. Sometimes your controller file may not work too, so you may need to reload the world file you are in. So here you can see our bot has started its motion. The first small turn, it passes over successfully. Now we are getting a sharp turn. Oops, here you go. Our bot didn't clear the second challenge, did it? So you can clearly see, although it has cleared the simple turning challenge successfully, it has failed at the sharp turn case. So this shows us that we need more amount of sensors to have a track of or have an idea of what position our bot is in. In order to tackle various challenges our track may offer us, circular or sharp turn, we need to be prepared with sufficient amount of sensors. So now you have an idea how to code with two IR sensors. I guess this is a sufficient cushion for you all to try your ideas with four IR sensors and give your bot an optimum chance to clear any challenges it faces while traversing over the black track. So this is all for this session. Thank you all guys. Cheers.